Mining is one of the toughest, most power-hungry industries on the entire planet. And for decades, its lifeblood has been diesel fuel. But what if we could change that? Today, we're going to dive into a pretty groundbreaking study that created a real-world blueprint for taking a deep underground mine and making it fully electric. For as long as anyone can remember, this has been the sound and the symbol of mining. The massive, incredibly powerful diesel haul truck. It's an absolute beast, right? It's essential for moving millions of tons of earth. But all that power comes at a cost. We're talking noise, heat, and of course, a massive carbon footprint. So that brings us to the big question, the one at the heart of all of this. What would it actually take to unplug this entire industry from fossil fuels and plug it into a battery-powered future? It sounds like a monumental task, and, well, it is. Okay, so to really understand the solution here, we first have to get our heads around the problem. The challenge of electrifying a mine isn't just about swapping out a few engines. No, it's about completely reimagining the entire underground environment. Now, check this out because the contrast here is just immediate. On the left, you've got the harsh reality for miners today, toxic exhaust fumes, intense heat pouring off those engines, deafening noise, and constant bone-rattling vibration. But then you look to the right and you see the promise of electric, cleaner air, cooler temperatures, much quieter operations. This is a massive leap forward for worker health and safety, and that's before we even start talking about the environmental benefits. So how do we get from the world on the left to the world on the right? Well, that's where this landmark project comes in, the Cosmos case study. And let me be clear, this wasn't some computer simulation. This was a deep, practical, nuts and bolts analysis of a real-world working mine. And here it is. This was the proving ground, the Cosmos nickel mine in Western Australia, a deep, complex operational mine. The goal was to figure out in painstaking detail if you could take a mine just like this and convert its entire mobile fleet, we're talking everything from the biggest trucks to the smallest vehicles, over to battery electric. Now, this was not a solo effort, not by a long shot. It required this really unique collaboration. You had IGO, the mine owner, who was already committed to clean energy. Then you had Parenti, the experts in the day-to-day nuts and bolts of actually running a mine. And then you had ABB, a global leader in electrification and automation tech. This combination of the owner, the operator, and the technologist, well, it was basically the perfect team to tackle this. So you might be asking, why this specific mine? Well, the crucial detail is its design. See, Cosmos has this massive 1,000-meter deep hoisting shaft that's basically a giant elevator for the ore. And this is key because it means the trucks don't have to make those long, grueling, battery-killing trips up steep ramps to get to the surface. The routes were shorter, which made them a much better fit for current battery technology. But of course, even in a nearly ideal location like this one, the path to electrification is just filled with major obstacles. A huge part of the study was identifying every single one of them and creating a realistic plan to solve them. It's a totally fair question, right? Why can't you just buy some electric trucks and get going? Well, as the study found out pretty quickly, it is way, way more complex than that. The hurdles are just immense. You've got the super high upfront cost of the vehicles themselves, but believe me, it doesn't stop there. You have to literally redesign parts of the mine to accommodate charging. You have to install a whole new, complex power infrastructure. And on top of all that, you're dealing with technology that's changing by the minute and a workforce that needs a whole new set of skills to operate and maintain these advanced machines. But here's the thing. For every single one of those challenges, the team worked to find a practical solution. They weren't just pointing out problems, they were building a playbook, a real playbook for the entire industry to follow. So let's take a look at what that playbook actually looks like. Okay, this is where it gets really clever. The solution wasn't just one single thing. It was a whole system. They planned for a mix of fast charging stations for quick opportunistic top-ups. But for the heavy-duty workhorses, the trucks and loaders, the key was battery swapping. So instead of a truck sitting idle waiting for a charge, it could just pull in, swap its depleted battery for a fresh one in minutes and get right back to work. It's all about minimizing that downtime. And the process they followed was just incredibly methodical. First, they looked at every available electric vehicle on the market. Then, they selected the absolute best tools for this specific job. In this case, a 65-ton Sandvik truck and an 18-ton loader. And then, crucially, they integrated the power source directly into the miner's workflow.
placing charging hubs in high-traffic spots like workshops or break rooms, making charging just a natural part of the daily routine. So they created the plan, they ran all the numbers, and they modeled the entire operation. And the results they came back with were, in some cases, genuinely surprising. Let's start with the biggest barrier, right? Money. The final conclusion from the study was crystal clear. While yeah, the initial investment is high over the entire life of the mine, the total cost to go all electric was not prohibitive. This was a huge finding. It basically said the economics of this can actually work. And here's the next bombshell. You see, diesel engines produce a massive amount of waste heat, and that requires these enormous energy-guzzling ventilation and cooling systems to keep the mine workable. But electric motors, they're more than twice as efficient and run way cooler. The result? They'd only need to run the bulk air cooling for 2 months a year instead of 5. That is a staggering amount of energy saved. And this leads us to the most powerful, most counterintuitive conclusion of the entire study. You would think, right, that plugging in a whole fleet of giant trucks would send the mine's electricity bill through the roof. But because the energy savings from ventilation and cooling were so immense, the all-electric mine was actually calculated to use less total power than the diesel version. Seriously, let that sink in for a second. Going electric actually lowered the mine's overall energy consumption. So what we're seeing from the Cosmos study is way more than just an interesting data point. It really does represent a potential turning point for the entire global mining industry. So what you should really take away from all this is that electrifying heavy industry, it's not a theoretical dream anymore. The Cosmos study proves that it is technically feasible and it is economically viable. It provides a real, practical roadmap for decarbonizing one of the most difficult and most essential sectors on the planet. Think about it. The Cosmos study proved that the technology exists, the economic case can be made, and the benefits for safety and the environment are just undeniable. So if one of the most complex, harsh industrial environments on Earth can go fully electric, the real question we have to ask is, what's stopping everyone else?